now that we are reasonably comfortable with variables, we're going to move into a new topic. So that's going to require that we start a new project. So we're going to go back to our Java projects folder, which is in Documents, Java Projects. And we're going to make a new folder. And we're just going to call this one Conditions. So this is going to introduce us to a new chunk of Java material. So we're going to go into the Conditions folder like we did before, and we're just going to type CMD up here to bring up our command prompt window, and we're going to type Gradle init. Again, like we've seen before, Gradle does take a little bit of time to boot up the first time you run it, and I have definitely restarted my computer since the last time we ran Gradle. So it's going to run, boot up, and like before, we are going to select an application, which is number 2. And then we should be able to select all the defaults for the remaining options. So implementation language is Java. Split functionality should be no. Build script Groovy is fine. Unit testing JUnit 4 fine. Project name conditions perfect. Source package conditions also good. And now it is built. So we can close this window, and here's our project. So we'll launch VS Code. I have already closed my project from last time, but even if you haven't, you can just go to File, Open Folder, and remember we're going to Documents, Java Projects, Conditions. Conditions is selected here. We'll select the folder. We can close the Getting Started tab. And like before, we're going to do some cleanup on this project. So we're going to the test folder and delete this app test file because we don't need it. And we're going to go into our main folder, Java, go into the app file, and we're going to delete this public string get greeting method. Remember, we don't want to delete the curly braces on app. We just want to delete the curly braces on this get greeting method and the rest of it. And then we just want to delete this line out of main so that our project looks like this. And we'll save that. So right now you can see that my Java extension is still booting up. So we're at about 60% there. But like before, we see that we're in the conditions package, which is the name of the project we made. And so we're now working in this new project. We're still going to use some of what we saw with variables, but in terms of variables, most of the new content that we look at here is going to be in terms of Booleans. So just as a brief recap, let's look at Booleans. We can create a variable called Boolean, and we'll say it's a sample Boolean, and we'll give it a value false. Okay, and I can print that value, and we can see that my sample Boolean ends up being false. And if it were true, we can run that, and we can see true here. So this is just a reminder that we can take a Boolean and set it equal to the value true or false. Booleans can't be anything else. Which sounds kind of boring, and it kind of is. But we can generate Booleans in other ways. And the first way we're going to look at doing that is with something called comparisons. In Java, there are 6 ways to compare things. And most of them are going to be pretty obvious to you based on what you've seen before. The two that you're definitely familiar with are these symbols. This symbol means less than, and this symbol means greater than. Okay, so we'll delete these lines and let's create some variables. So I'll say A equals 5 and B equals 7. And I'm going to create a Boolean, and the Boolean is just going to be A, or well, actually we'll just make it greater than for simplicity. And we can say that greater than is equal to A greater than B. And we'll system.out.println greater than. Right, so this is enough code to actually run a program. And here we have the condition. So the greater than symbol is a condition, and it checks, is A greater than B? Well, A is 5 and B is 7. Is 5 greater than 7? Let's see. I hope not, but we end up getting false. What if A were 6? Is A greater than B? Still false. Okay, what if A were 7? Is A greater than B? So the question now becomes, is 7 greater than 7? And the answer is false. 7 is not greater than 7. But what if A were 8? Is A greater than 7? And it is. So greater than tells you is the number on the left greater than or bigger than the number on the right. We can also get less than with A less than B. So we'll do system.out.println less than. And we want this to be a little more readable, so I'm going to add a string. And I'll just say greater question mark and the value of greater than. And we'll say less and get the output there. And so we're checking A is 8, B is 7. We're checking is A greater than B and is A less than B. So I'm going to clear this out and we'll run this. So is 8 greater than 7? Yes. But is 8 less than 7? No. So greater is true and less is false. And if I bump this up to some much larger number, okay, I still get true and false as I would expect. And if I bump this all the way down to 6, 6 is not greater than 7, but 6 is less than 7. Okay, and they flip. Greater is false and less is true. Because 6 is not greater than 7, but it is less than 7. So I'm hoping that that kind of matches your intuition. And so far it looks like if one of these is true, the other is going to be false. But if they're the same, and we run that, they're both false. Because when the two numbers are the same, neither is greater, neither is less. So they can both be false, but they can't both be true. And so that's something to keep in mind, is that if one number is bigger than the other, you're going to get a true for greater than, you're going to get a false for less than, or vice versa. But if they're equal, you're going to get false for both of them. Because greater than and less than only check, are they greater than, are they less than? Okay, but then we have two more operators. We have this operator, and we have this operator. And so these are actually two symbols together. This symbol means less than or equal to, and this symbol means greater than or equal to. And so this is where things get a little bit more opaque. We have a greater than or equal to, where A is greater than or equal to B, and a Boolean less than or equal to, where A is less than or equal to B. And we are going to need two more system out at println. We'll say greater or equal and greater than or equal to. And we get a system.out.println less or equal with less than or equal to. So we'll go back to what we were doing before. We'll say 8 and 7. Okay, is 8 greater than 7? So that's true. Is 8 less than 7? That's not true, so that's false. Right. Is 8 greater than or equal to 7? It is greater than. It's not equal to, but it is greater than, so that's good enough. And is 8 less than or equal to 7? It's not less than 7, and it's not equal to 7, so that's false. So we should see true, false in the output. So we'll run it. True, false, true, false. So let me bump the 8 down to 6. Is 6 greater than 7? Well, that's false. Is 6 less than 7? That's true. Is 6 greater than or equal to 7? It's neither of those things, so it's false. And is 6 less than or equal to 7? And it is less than. It's not equal to, but it is less than. So that should be true. So we're going to get false, true, true. And we run this. False, true, false, true. So we do get that flip again. So it looks like, so far, greater and greater equal are going to have the same answer, and less and lesser equal are going to have the same answer. And then the two pairs are opposite of each other. So you try to look for patterns here, but be careful, because when you find patterns, the patterns may just be something you think are there, because we still haven't tested this case. Okay, now they're the same number. Is 7 greater than 7? That's not true. Is 7 less than 7? Still not true. Is 7 greater than or equal to 7? Now 7 isn't greater than 7, but it is equal to 7. So that's true. Is 7 less than or equal to 7? Well, it's not less than 7 because it is 7, but it is equal to 7. So that's also going to be true. So we should see false, false, true, true, which is what we predicted. There are two more comparisons, and this is where notation gets really important. If you want to check if two numbers are the same, remember, we don't use the equal sign for equality. Equals is the assignment operator. It means gets the value. If we want to check if two numbers are the same, we use two equal signs, which means are equal. So we'll have our Boolean are equal is A equal equal B. Now when A is 7 and B is 7, they are the same, so that should be true. So system.out.println, we'll just say equal, and we'll say are equal. So same as before, false, false, true, true, but now they are equal, so this last one should also be true. False, false, true, true, and they are equal, so that's true. Okay, and if we were to go back to one of our examples and say, okay, let's make a 6. Six is less than 7, so it's not greater, so both of our greater thans are going to be false, and they're not equal. so this one's definitely false. 6 is less than 7, so both of our less thans are going to be true. And 6 is not equal to 7, so this should be false. So we should get false, true, false, true, false. And we get false, true, false, true, false. And last one, back it up to 8. 8 is greater than 7, so both of our graders will be true. A is not less than 7. A is not less than 7, and it is not equal to 7. And 8, again, is not equal to 7. So this time we should get true, false, false. We'll run that. True, false, false, just like we predicted. And so there's one more comparison we can make, and that is are not equal. So that's the exclamation point with one equals sign, and that is are not equal. So we'll throw in another Boolean, are not equal, and that's the same as A not equal B. Just know that sometimes when you see the exclamation point, it's read as the word bang, B-A-N-G. And we'll add one more system out, println not equal, and we'll say are not equal. So 8 and 7, we know the graders are true. Less than or equal to are both going to be false here. Are equal, okay, 8 is not equal to 7, but is 8 not the same as 7? Well, that's true, because 8 is not 7. So we'll get true, false, false, true. And we'll run this. We'll see true, false, false, true. Oops, I need to put in another space to make it pretty print. There we go. And now we'll flip it with 6 and 7. The graders, let's see, greater than. 6 is not greater than 7. 6 is less than 7. 6 is not greater than or equal to 7. 6 is less than or equal to 7. 6 is not equal to 7. And 6 is not equal to 7. Okay, so we should see false, true, false, true, false, true. False, true, false, true, false, true. In our last case, we'll do 7 and 7. 7 is not greater than 7. 7 is not less than 7. 7 is greater than or equal to 7. 7 is less than or equal to 7. 7 is equal to 7. And 7 is not equal to 7. So be careful with your double negatives there. But we should see false, false, true, 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 false. So if we'll run that, we'll run it up here. False, true, let's see, false, false, true, 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 false. So you might be inclined to find some relationships here, and relationships do exist. Which ones are opposites? Okay, well, the most obvious opposite is that equals and not equals are opposites. These two will always be the opposite of each other. So if one thing is equal, it can't be not equal. If you've been looking, you might have picked up on some of the others. It looks like greater than and less than can be the same here, so they're definitely not opposites. Greater than is actually the opposite of less than or equal to. And the reason for that, let's see it with an example. If we look at 8 and 7, 8 is greater than 7, which is the opposite of saying 8 is less than or equal to 7. Okay, so 8 is greater than 7, that's true. 8 is less than or equal to 7, that's false. What if I flipped the numbers? 7 is greater than 8, that's false. 7 is less than or equal to 8. That is false. Or actually, that's true. So they're still opposites. And the last case to check is, are they equal? Is 7 greater than 7? That's false. But is 7 less than or equal to 7? That's true. So they're still opposites. If I just had the less than sign here, both of these are false, which means they can't be opposites. And so the opposite of less than is greater than or equal to. So these are your 6 comparisons, and these are the 3 ways they show up as opposites. Big takeaways here are the double equal sign will tell you are 2 variables holding the same value, whereas the single equal sign will assign a value to a variable. The other big takeaway are these opposites. The equal is the opposite of not equal, and that should be kind of obvious. But these are a little surprising the first time you see them, but the more you play with them, the more they make sense. So you can try these with any integers, and you'll get all the results you expect here. And if you are getting results you don't expect, double check your logic. You might be missing something in your understanding, because these all behave a very specific way. The only time you really need to be careful is when you're dealing with doubles. So we'll test this out with doubles briefly so that we can get some intuition there. The thing to know about doubles is that these 4 operations, the greater than, less than, greater than or equal to, less than or equal to, all the ones with the greater than or less than symbol, those are going to behave exactly like you expect. The ones that you got to watch out for are the are equal and are not equal. So just a quick rundown with 7.0 and 7.0. If we run that, okay, they are equal and they are not equal. That's good. And again, these 4 are going to all act the same as you would expect. These might not. It's a little bit tricky, but the one you really got to watch out for is, let's see this. 1.0 and 0.1 times 10. Now I've written these 2 numbers are written different, but 1.0 and 0.1 times 10 should also be 1.0. So these 2 numbers should be exactly the same. So as I run, I get equal, not equal. Okay, so that's working fine. What about 0.2 and 0.1 plus 0.1? So again, I've just written these 2 numbers differently, but they are the same. If I run that, equal true, not equal false. So far the doubles are acting pretty much as I would expect. Let's try 2, and let's try 20 divided by 10. And remember, this is going to do some integer division, so let's make sure we add in some point zeros to make sure Java treats them like doubles. So this is another example, and again, we're getting results that we're expecting here. So nothing too out of the ordinary. So let's try 0.5 and 0.2 plus 0.3. So again, they just look different, but they are the same. 0.5 is the same as 0.2 plus 0.3. Okay, are they equal? True. Are they not equal? False. So that's good. Let's add in a few more zeros here, just so that we can see a little bit of a difference. Very small numbers we start to see. 0.005, 0.002 plus 0.003 should give me all the same results. And so far they do. So far I don't see any issues. Let's try writing this a little bit differently. we'll try 0.1 a few times. Let's see, there's 4. I'm just going to write it out as best I can. And there's 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Run it again. And this looks a little bit weird now because it says they are not equal. It says they are not equal. Let's check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's weird because 0.1 10 times is the same as 1.0. So let's double check real quick what's happening, because we should have expected those to be the same. And notice that are less than or equal. Only one of them was right, even though it is equal. So something is happening with equality with our double. Let's see. And here we can see the problem. A is 1.0, but B is 0. And a whole bunch of 9s. This isn't a bug in your program or my program. This isn't a bug in Java. This is related to computers. Computers store numbers as binary. Everything is going to be a 0 or a 1 in binary. Not every number that you can represent in base 10, in decimal, can be represented perfectly in binary. 0.1 is one of those numbers. Even though that right here I wrote 0.1, Java stored the double 0.1 as an approximation of 0.1. Something very, 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 very close to 0.1, but not exactly 0.1. And the problem is I did that 10 times. And if the more and more you do that, you approximate a little here, a little there, it starts to add up. And what happened is we saw it here, but we didn't see it when I did 0.2, is because we'll double check that just to check it. 0.2, and okay, we'll run that. Okay. It looks the same, and that's because our approximations didn't accumulate enough problem. Here, they were allowed to accumulate. There were much more approximations made, and so now we see the difference. All this is to say is that when you're working with integers, you can use all 6 comparisons perfectly. When you're working with doubles or floats, you can't use all of these perfectly. Anything that's relying on equality is not going to work. There are ways around this, and we might look at that in a future video, but right now just understand that you cannot compare doubles for equality. That means that are not equal, are equal, greater than or equal to, less than or equal to. These 4 are not going to work as you expect them to. Now, less than and greater than are usually okay if you're not worried about exact equality. And even these 2 are going to be okay as long as you're not worried about exact equality. But just be aware that when it comes to saying, is this double exactly the same as this other double, you're not going to be able to reliably answer that question. With integers, it works perfectly because whole numbers are easy to represent in binary. In decimal numbers like doubles and floats, it's not. But again, there are ways around this, and hopefully we'll get a chance to look at some of those methods. And Java has other tools where you can work with decimal numbers. Java has a class, a type called decimal, which is a perfect representation of decimal numbers, but it's very slow and inefficient compared to doubles and floats. And so you don't see it as often. So just be aware that these are your 6 conditions, and you can use them all with integers as much as you like, but you should really only be using the less than and greater thans with doubles And you can use the less than or equal to and greater than or equal to with doubles as long as you're not relying on them being perfectly equal. These two I would not use with doubles ever because you cannot rely on them. But with integers, they're fine, and integers are where you're going to use these a lot when you're first starting out, and especially with what we start looking at in the next few videos. But the less than and greater than will show up with doubles from time to time. But these are the 6 ways we have to generate Booleans when comparing two numbers, and these are their relationships. So a good practice now would be to create some variables and do the comparisons yourself and see, are the comparisons generating what you expect, and are the opposites behaving as you would predict. Once you get comfortable with these comparisons and the Booleans they'll generate, you can start looking at the next videos, because this is going to be very foundational for what comes next.